So hello everyone. Today we are going to discuss Code Forces round 892 Division 2 problems A to D. So let me start with the first problem. United we stand. तो इसमें क्या था इसमें like n length का एक array दे रखा था and there were two empty arrays initially B and C. So what we had to do is we needed to add each element of array A either in array B or in array C. So it is given here both the arrays should be non-empty. So basically, we should add at least one element in either one of them. In both of them, we should add at least one element. So and one more condition is there for any two indices I and j. Cj should not be a divisor of b of I. So basically, what it is saying is uh, what they're saying is like if there is an array something like 1 3 7 9 or 10 anything like that, so we have to make two arrays b and c. So b and c both should be non-empty, so we should give at least one element to either one of them, to both of them. So let us give one element each, and let me give it a 7 and let me give it 10. Let me give c 10. So uh, yeah, someone is trying, yeah. So like one there is one more condition, like any of the elements of C should not be a divisor of any of the elements of B. So यहाँ पर ये satisfy हो रहा है because if you see 7 and 1 का कोई भी divisor नहीं है. 3 and 10 are not the divisors of 1 and 7. So we are safe here. But what should we do in order to be safe every time? Like what is the ideal criteria? So if we take the maximum element of A, then it won't be a divisor of any other number other than the number itself. So let me consider here, like there are many tens, right? So what should I do? The maximum is 10. So if I give one 10 here and other 10 here, then it would it won't like satisfy my condition. So I have to put all the maximum elements here. So all the 10 should come here and all the leftover elements can come in B. There's no issue in that, right? So like this was the major criteria that this was the main approach we had to think about. And now there is one more thing that if output the arrays B and C, we have to output both the arrays that can be obtained, or output -1 if they don't exist. So in which case they won't exist. So the case where there is only one element in the whole array, basically not exactly one, all the elements in the array are equal. So if all the elements in the array A are equal, then the answer would be -1 because you would have to put all the tens in one of them. You can't put in like both of them, otherwise it won't satisfy the condition. Yeah. So if all the elements are equal, we have to print -1. Or other than that, like we'll just take the maximum element. So if you can see here, the example 2 comma 2 comma 2, it is giving -1. The next example is 1 comma 2 comma 3 comma 4 comma 5. So we can do one thing. We can assign 5 to C and 1 2 3 4 to B. So like my solution is also like this only. It is quite simple. So I take basically I find the mx is the maximum. So I find the maximum. Then if a of I equals to maximum, I push put it into the vector C. Otherwise, I put it into the vector B. So if both have a size, basically this statement means that uh, none of them is empty. So I print the sizes and print the arrays. Otherwise, I print -1. So I'll move on to the next question. If anyone has any doubts in this question, can ask me. So the second question is we have a 2D matrix. Basically, we have n arrays, and each of the arrays has some size n. Like uh, each array has a variable size, right? So what we can do is the thing is we can move one element from one array to any other array. So Consider that there are many arrays. A1 equals to 1, 6, 2, something like that. A2 equals to 2, comma 7. A3 equals to 5, comma 9. Something like that. Okay. So what we can do is what kind of operations can we make? From any of the array, like we can move one element to another element, but at most one time. Like it is written here, I guess. Yeah, here. So yeah, Olia can move at most one element, possibly zero integer, at most one possibly zero integer from each array to another array. So she can move one element from an array to any other array. Uh, the important thing to note is that integers can be moved from one array only once, but integers can be added into some other array multiple times. So basically, it says that you can add the elements into any array any number of times, but you can remove it only once. So basically, if I say I have to remove one from here and add one here, I can do that, but I can't remove some other element. I can also do one more thing. I can remove 5 from here and add 5 here. I can do that. Then I can remove some element from here like 7 and put it here. Like I can do something like this. So basically, what the question wants. So let us see what the question wants. So the beauty of the list of arrays is defined as the sum of the minimum of each array. So we want the maximum beauty. So beauty is basically if we look into the current scenario, what is the minimum of this array? It is 1. What is the minimum of second array? It is 2. And what is the minimum of the third array? It is 5. So basically the sum is 8. So we want to maximize the sum, I guess. That's what they want, right? Maximize the beauty of the layer. Yeah, we want to maximize the sum. So how can we maximize the sum? So, if we look into it, what is the maximum increase for a particular array for in its minimum? So basically, if I remove the minimum element from that array, I can achieve a new minimum, which is obviously greater than the previous minimum, greater than equal to the previous minimum, and I can remove it only once. So maximum possible minimum for this array is 2. Let me assign it the value 2. Then for this, what is the second minimum element? 7. And my bad. And what is the second minimum element of this array? It is 9. So basically, I'm calculating the second minimum element of each array, because the thing is I can remove their minimum elements and put it in some other array. But I can't take the second minimum element for every array, because I have to put it somewhere, right? I can't just destroy the number. So I have basically, if I see what is if I see there should be some minimum number of among all the elements in all the arrays. So here it is 1. So basically 1 has to come in some or the other array, right? So 1 has to come in some array. So what if I put a minimum of all the arrays in the same array as the minimum element of the whole of the bunch of numbers? If I do that, basically I'll save myself from decreasing the minimum of some good arrays. So basically, I put all the minimum elements in in one array only, and I have to choose which array is that. So basically, that array would be the one which has the second minimum as the minimum value. Basically, if I see 2 is the second minimum of this, 7 is the second minimum of this, and 9 is the second minimum of this. So if I put all the minimum numbers in this one, the thing is the second minimum value of this array is the minimum. So I can basically decrease its minimum. It won't make a big like it won't cause me a much problem. If I do this in this array, the thing is my minimum would reduce to 1 here. The minimum has to reduce to 1 for some of the array, some array among these arrays. So let it be this array, right? It would give me the maximum possible answer then. For this, the answer would be 7 plus 9 plus 1, 17. If I put 1, 2, and 5 here, then the problem is that the answer would be 2 plus 1 plus 9. So I have to choose the minimum the array which has the minimum second minimum. So like if I look at the examples, so the first example is 1 2 4 3 1 2 3 4 basically. I have only two arrays here, not three. So what is the second minimum here? It is 2 here, it is 4 here. And if I do 4 plus 6, 4 plus 2, it is 6. Now I have to choose the minimum one from them. So I have to subtract that minimum and I have to add the overall minimum of the whole array, which is 1. So basically its answer would be 5. Let us see if it is 5. Yeah, it is 5. So for the second test case, the answer is quite simple. So we don't even need to do anything. And for the third one, we can still like work on it. What is the test case? 1001 71007 71007 and 5. This is the first array. Now let me see the second one. Second one is 8 11 6 and third one is 2 comma 9. 8 11 6 2 9. 8 11 6 it is 2 comma 9, right? So what is the second minimum in this array? It is 7. Here it is 8. Here it is 9. So if I take the sum of each one of them, 9 plus 8 plus 7 minus 7 because 7 is the minimum, and I'll add the minimum element of the array, which is 2. So it sums out to be 19, and this should be the answer, I guess. Yeah, it is the answer. So basically, this is the approach, and if anyone has a doubt, can ask me. Now moving on to the third problem. Uh, so it and there is yeah. So the problem is let's call the cost of a permutation of length n the value of expression p of I into I minus someone is asking, can you tell me how to solve the second question? Um, you got my approach, so what are you exactly asking? Okay, like I'll show you the code once for the second question. Wait a minute. So implementation is quite simple, right? I just iterate through all the elements. I take the overall minimum. I then like I make a vector of vector. Basically, it is a vector of array. Like if you don't get it, you can make a vector of vector. That would be much simpler. Then for each of the array, I add the elements in it. Then I sort each of the array. Basically, V of I is an array. So I sort all the arrays like this. And after that, what I do is basically I take the second minimum. So second minimum is the like one indexed element for that. So I add second minimum in the answer for each of the array. Then I take the minimum of all the second minimums, right? So what I do is I add for I subtract the second minimum, and I add the overall minimum of the array, which is n. Did you get the implementation? Got it. What will be time complexity? Time complexity is obviously let me see, n into m, I guess. Yeah, n into m, obviously the time complexity. So O of n into m, which is the expected time complexity. So let's move on to the third problem, and like yeah. So the cost of a permutation is the sum of p of I into I minus the maximum among all the p of I into I. So basically, if I take a permutation like this, uh, 1, 4, 2, 3. So I have to calculate the sum of P of I into 1 into 1 plus 4 into 2, right? Plus 2 into 3 plus 3 into 4. Now, after that, I have to subtract the maximum among all these products. So the maximum among all these products is 3 into 4, right? So I subtract 3 into 4. So it what does it give me? It gives me the leftover answer 6 plus 8 plus 1, which is 15. Like this is the cost of a permutation. So for a given size n, I have to calculate the maximum cost of a permutation for that size. So basically, if I take the size 4, so for 4, I have to calculate the maximum cost for the permutation. So for for this particular permutation, it is 15. So I have to check all the permutations for that. Like if I really want the maximum answer, but I have to find like an optimal way, because the value of n, if you see, is 250, right? So at max, what could be my time complexity? Like of course, if you see like the sum of n over all the test cases is 500, you like the first thing that comes to our mind is O of n cube, time complexity. But like if you work it out smartly, if you really see why n is less than equal to 250 if the sum of n is 500, like you can figure out what would be the ideal time complexity for it. So for this particular for this question, the time complexity can be n cube log n. And why is that? If you carefully see, like the maximum value of n is 250, right? And if it is the maximum, if we take the maximum possible n, so there would be basically two test cases, max to max, because sum of n can't increase 500. So if I do 250 cube into log 250, then I just have to multiply it by 2 and like check the time complexity basically. So if I like see what is if you see 250 cube into log 250 into 2, it is well within the time complexity limits. So we can apply n cube log n for this question. It was a really important observation, because like if you apply the brute force approach, it would take n cube log n. So my approach was brute force only. So like I have to check for the all possible cases, right? So if you see if for a particular permutation, if we don't have to subtract anything, like assume that you don't have to subtract anything, what would be the maximum possible permutation? Like what basically what is the criteria for that? If you see, we have 1, 2, 3, 4 these numbers, and another list of these numbers 1, 2, 3, 4. So basically, we have to match something from this. Like we have to match something from the first list to another thing from the second list, and we have to multiply them. So obviously, the maximum sum would come when we multiply the maximum numbers from it, right? So obviously we would greedily multiply the maximum numbers, 4 into 4 plus 3 into 3 plus 2 into 2 into 2, 1 into 1. It would always give me the maximum sum. But the problem was that like I had to subtract the maximum product from it. So it might not give me the optimal answer. So if I like, if for an instance I iterate on all the possible maximums, like what I can do is I can iterate all the possible pairs and consider that it is the maximum of the permutation, right? If I do this for int j equal to 1, j less than equal to n, j plus plus, so I'm considering mx max equals to I into j. So now can I can I figure out the maximum? So what would be the maximum in this case? So if I take all the numbers 1, 2, 3, 4, 5, I'll just remove I from the first list, right? If Let me consider I is 5, so I'll remove 5 from the first list, and if j is 4, I'll remove 4 from the second list. So how would the how is it going to proceed? So obviously I'll take the maximum number in the first list and check the maximum number in the second list. But I have to take that particular number which is less than equal to this number, right? Obviously, because it is the maximum. So I have to take some number which is less than equal to this. So what is I into j? Basically for 5 and 7, max is equal to 20, right? So it should be less than equal to 20. Yeah, Yogesh, it is the brute force approach. Like brute force, like not hardcore brute force, but like if we iterate on all the maximum, that kind of brute force. So of course now like I have 7, I have to check which is the maximum possible number I can take with it. I can't take 3, I have to take 2 only, because 7 into 3 is 21. So how would I how would I find the maximum number? I can do one thing. I can take the first list in a vector and the second list in a set. So I can use one thing. I can do max by 7. Basically, max by 7 would be the maximum possible number it is going to go. Like I want something less than equal to this number. Int k equals to max by 7. So now I have to check in the set which is the number less than equal to k. So I can apply upper bound s dot upper of k minus 1. Basically, I'm subtracting 1 from this iterator, minus minus. So this is the iterator that would give me the ideal result. For 7, it is 2. Now, if I consider for 6, it is 3. You can see 6 into 3 is 18. For 4, it is 5. For 3 it is 6, for 2 it is 7, and 1 it is 1. So basically for a particular maximum I can get the maximum possible result. So I have to iterate over all the possible maximums, and I have to calculate this number and take maximums among all of these. But there might be some cases where like you won't be getting any consider if the maximum was 6, like if I was 1 and j was 6. So there is no number for 7, right? Like 7 into 1 is obviously greater than 6. You can't take any number for 7. So in that case, like you won't be considering the answer for the basically you would be like you won't be considering this maximum. You won't be considering the answer for this maximum. You will proceed further. So that's how we are going to solve this question. We are going to iterate through all the possible maximums, and we are going to match the leftover numbers in the maximum possible greedy way. So basically, this problem is a kind of brute force greedy types. Uh, so we can solve it like this. If anyone has any doubts, can ask. I'll show you my code for once. So I'm iterating I and j. I have taken I and j. Then I insert. Basically, I take two lists, one as vector, one as set. I insert all the numbers except this j, and I insert all the numbers except I in this list. Then I basically this is the list V is in increasing order, so I'll basically back propagate from it. So I take the last element of V, uh, and I into j by v dot back. I into j is the maximum, so I take upper bound and subtract the iterator from it. And like this, I just calculate. Basically, I keep on increasing the products. Basically, yeah, add it on to the sum, and yeah, and I take maximum with the answer. So this is how I have implemented it. If anyone has any doubts, can ask. I'll move on to the next question. So in this question like there are yeah, so there are a lot of teleports here. So how is a teleport defined? There are basically a lot of ranges. If you can see, there are a lot of ranges. L, R, A, B. A particular teleport is defined like this. If you are in the range L to R, you can basically like teleport to any of the locations from A to B. So basically you have to be in any of the some locations from L to R, and you can teleport in A to B, and you can use like this operation several times. And from a particular point, you need to reach the maximum possible point. Yeah, like you have to check what is the maximum possible point that you can reach, right? So there would be some like there are some queries given. So for each query, you have to calculate the maximum possible distance it can reach. So it is solely dependent on A comma B, because basically the one more condition is given that A comma B is inside L comma R. Basically, if L to R is the range, basically consider 1 comma 5. So you can teleport to 2 comma 3, something like that. You will be teleported in between that range only. You can't teleport outside. So if I have to basically if I can do one thing, I can calculate for each of the teleporters what is the maximum range they can reach. Basically, multiple they can be multiple teleports. That's why like you can get a maximum range, right? So for each teleporter, if I can calculate what is the maximum range it can reach, so it depends on it obviously depends on if A comma B is like is in the range of some other L comma R, L comma R of some other teleport, then only like there is a possibility that it can teleport again and again and reach a maximum. So if we want to calculate the maximum distance it can reach, so we can do one thing. We can start with a teleporter which already has the maximum like possible distance. So what we can do is the obviously the maximum distance depends on B only. Like what is the maximum coordinate it can reach? It depends on B. Because in the end you are going to teleport at B for every teleporter, right? So if I like uh, start from the teleporter which has the maximum B, what I can do is I can sort all the teleporters according to B. So I start with the maximum teleporter and calculate the maximum for it. So I have for this one I can easily say that the max is B only. Now the thing is, if I talk about the other teleporters that are going to come in this order, so obviously I can say that the B of the next teleporter would is going to be less than this one, right? Basically next B is going to be less than equal to B, and also less than equal to R, because B is less than equal to R. So basically next B is less than equal to R for sure. This is for sure. Now if this B has any chance the basically the next B would have the chance to increase its maximum only if the L for the previous teleporter is less than equal to this B. So what I can do is I can make a uh, multiset. What I can do is I can insert in that multiset. Once I iterate through the teleporter, what I can do is I can do one thing. I can do L comma the max it has. So basically, I would have an idea that uh, what all else are less than equal to the this B. Basically, for a particular B, the answer only depends on all the else which are like less than equal to this. Less than equal to itself. Basically, yeah. So please explain the next P thing once again. From next P, I mean that like let me take an example that would be quite easier for you to understand. So 6, 17, 7, 14. Let me take an example. This as an example. So let me. So if this is an example, so I sorted by B. So first of all, I'll go to this one, right? It has the maximum B. So I'll calculate the max for this teleporter. So max of 3. Basically, let me assume that this is the teleporter 3. So max of 3 is 22, right? Now, the L for this teleporter is 16. So what I can do is I can put in a multiset. Let me name it MS. I can insert 16 comma maximum in this, and I can take another multiset which basically gives all the values which are maximum basically. So let me name it r dot insert 22. Why am I making two multisets? The thing is, I am making this multiset to calculate the maximum answer. But the problem is if there are some L's for which this maximum, uh, there are some maximum for which the L is greater than the current B. Basically, if I move on to the next number, for this, let me consider I have inserted these numbers. Then I move on to the next one, which is this teleporter. So B for it is 14. So all the teleporters which so basically L should be less than equal to 13, right? If B is equal to 14. So the thing is, first of all, I have to check in the MS. Basically, I'll check the last element in the MS. So while MS has a size, what I can do is I can check if the last element ms dot if ms dot last is greater than ms dot last dot first basically. Basically it is a pair now. So if it is greater than B, what I'll do is I would erase the last element, erase last, right? I have to erase this element, and before erasing that, I have to do one more thing. I have to erase it from this multiset also. That that is the significance of two multisets. Why I have used two multisets? Because I have to remove it from here also, right? So I have to make this multiset also to see which values are greater than it. So I'll remove all the values which are greater than B, and remove it from this multiset. So I'll do two operations. R dot erase last, uh, ms dot last dot second basically. So I'll go like this. So these two operations I have to do till the else happens. If the else statement comes, I'll have to break, right? Can we do merging of segments for which um see, like there are many approaches, like you can merge the segments, like, but I didn't like think on the merging part because like it might be like turn out to be wrong or something like that. So like I only went with this approach. So like if you feel like there is another approach and it is correct, you can share it with me. uh, but I have done the question with this approach only. So in the else condition I break, right, I have to break it because now all the elements are less than equal to this. That's why I was taking the maximum element of the multiset, right? So I remove all the elements which are greater than this number, and I do this, and after that, what I do is the max of this number, which is a max of 1, is equal to maximum of R basically. So last element of R, if it exists. If the size of R is 0, then I can easily I can only take this one, B, as the answer. So max of 1 here is 14 because 16 is greater than it. So max of 1 is 14. And I again insert 6 comma 17, ms dot insert 6 comma 17, not 17, basically 14, and r dot insert 14. Now the I move on to this one. So for this, if you can see, L is less than equal to B. So I can easily make max of 2 also equal to 14, right? So like in this way, I have calculated the maximum for each of the teleporters, right? This was one step. Now for queries, we have to take another step. Before that, someone has sent a message. Like these erasing elements from multiset, it ultimately becomes a merge segment, I think. Yeah, I guess it becomes the merge segment. But why to complicate things by like considering them merged? We can simply do it like this now. So once we have considered like taken the maximum for each of the teleporters, we can iterate through the queries. The thing is now we will do the offline. We won't be like calculating the answers online. We would be calculating offline. So offline means that we like first take the input, then we output it afterwards. Not we are not taking the input and then generating the output. We are taking all the queries as input once. Then I'm sorting all the queries because what I'll be doing is I'll be working in the sorted order so that I can like go step by step. So if I've sorted all the indexes, I have sorted all the queries. So what I can do is I less than q I plus plus. So if all my queries are sorted, if I have to check for a particular particular element, what is the maximum it can reach. What I can do is I have some particular ranges of teleporters and I have their maximums, right? So I can basically start a range. I can sort all the ranges L to R, and after sorting, what I can do is I can apply the two-pointer approach. So initially, it would be on the first element j equal to 0. So while j is less than n, and uh, yeah. So if I take teleport, the vector of teleporter as t. So t of j dot first means the L of the teleporter is less than equal to q of I. Then I'll add basically I'll add this in the multiset. I'll take another multiset. Basically why I'm taking multiset here also, because I want the maximum among all the ranges, because it might be possible like if I take for instance like if I take 6 here, right? No, let me take 17. If for 17 I have to calculate, 17 is there in two ranges, 6 comma 17 and 16 comma 24. So what should I, which range should I take? So I should take the maximum of both of them, right? So maximum is 22. So for that to happen, I have to see which all ranges are active. So to check all the which all ranges are active right now, what I do is I just see which all L's are less than it, and I add it into the multiset. Into a multiset, I take multiset m dot insert the max of j, something like this. Now I have to also check when is it ending. So for the ending part also, I'll make another multiset of pair again. So what I'll do is p dot insert uh, what the end when the range ends, t of j dot second comma max of j. So what I'll do is I have to add j plus plus also here. So now I have to check which all ranges have ended till now. So I'll again like see the last element of P. Sorry, the first. I'll start with the first element of P. Well, P dot size. I'll check if P dot begin is basically uh, expired or not. If P dot begin is uh, less than Q of I, it means that the like this range has ended. So I would have to like erase m dot erase it from the multiset m. Erase the maximum of it. So erase p dot begin of second, and else I'll break it. So in the end, what I'll do is I'll take the maximum of subset, basically maximum of this multiset, if it exists, if the size exists, and I'll take the one more thing I have to consider, that I have to take the maximum of the query itself, because it might happen like some number is 24 but it teleports to 22, but the maximum it can reach is 24, right? Because it started from 24. So why should I give the answer as 22? So I'll take the maximum as the maximum of the multiset and the number itself. So this is the approach for this question. I know this this approach is quite complex and it might be difficult to understand. But like you can always check my solution here, like under the account pbx_1. You can check my solution. It is quite complicated approach and lengthy. You might find better approaches. There might be better implementation, I think. But this is my implementation. So if anyone has any doubts, can ask. Otherwise, so thank you guys. Mm, okay, there is one question. Okay, so yeah, thanks a lot. So thank you for attending the session. I'm done with the discussion. So bye bye.